since we're going through this relatively fast, what I decided to do is just do this again with a data set, the KNN. Do it again with a different data set. So here I'm sending seed. It doesn't matter the seed number. The only reason why I'm using this is so I can get a particular same results if I would move to a different computer. The libraries that I'm going to get LeBron's data frame. Okay. What I'm going to do is I'm going to teach you what's going on here. So I can just run these lines here and it won't run line 19. So I'm going to do that real fast. Oh, that makes sense. Okay. All right. So we'll ignore that warning. It's not worth explaining. But let me go ahead and run this. Okay. So what's happening here in this modification one, is that we get some NAs. And I don't want NAs in my data set. I want to remove these NAs. So whenever I see an NA, I want it to be removed. Okay, so this filter function filters to say when, so is NA, so it's going to look for when minutes played is NA, and it's going to say not. So exclamation mark is not NA. So it's going to say, if it's NA, it's going to say true. However, I'm going to say not true, which is really false. So it's going to just remove, long story short, if that's confusing, all it's really doing is just removing the rows where there's NAs. Okay. Exclamation mark is NA for that actual column. Okay. And what I'm going to do from there is I'm going to plot this data. So again, we have two quantitative variables. And we're using the outcome variable. Our response variable is going to be the game outcome. So LeBron James minutes played, and points scored to predict the game outcome. So we run this. As you can see there, it's quite challenging to make such predictions, right? Because it's not clear. There's a relationship between minutes played and points, of course, for LeBron James. But in terms of what is going to happen if LeBron James doesn't score too many points, or his minutes played is, really high, let's say. We don't have that much data there, but still, it'll look for the nearest points, right? It'll look for, if this were to be the situation, it will look for two nearest neighbors or maybe three nearest neighbors, depending on what you set K to be, right? And that's going to determine how we're going to classify this to be either a win or a loss. Okay. So with that being said, this is just a way for us to visualize what's going on here. I'm going to do our traditional. I'm going to break the data frame into a train and test. Okay. As we've done in the past. And then I'm going to pull out the vector for the train and the test. And then I'm going to extract the variable game outcome, the response variable from our data frame. I'm gonna run this run this KNN, okay, the K nearest neighbor, and this time I'm gonna do something different. I'm gonna let it be 4 nearest neighbors. That's going to help detect the more neighbors that you look at. It's not always the case, but ideally, it could be the case that you get a better accurate measurement, right? So we're gonna run all these, okay. Run this one. And then here we're going to get our confusion matrix. And all I'm going to do with regards to this confusion matrix is just explain to you what's going on here. I mean, in terms of numbers wise. So LL is going to, let's say we're interested in wins, of course. LL is going to be my true negative. Win-win is going to be my true positive. Whenever this is my model, this is my prediction. Here, I'm predicting that they're going to lose, so this is going to be a false negative, right? In reality, they won, but I say that they lost using KNN. And then here is going to be my false positive. I see that they win, but they really lost. Okay, so there's a lot of things that can be done here. Intentionally keeping it short. I know if I'm fatigued, you're fatigued. So I'm not going to go too crazy. The only thing I'm going to mention is, let's say we just looked at 2 neighbors rather than 1. Rather than 4. Let's see what happens. Okay. these are our numbers. Okay, so the same false, this is a false negative, and this is a false positive, and this is a true negative, true positive. Same information is given to us, but different results. Tomorrow's Wednesday. We're going to do some other things. I'm actually going to talk about this concept called accuracy and precision using this confusing matrix. Okay. So thank you for your time. I know this is short. I didn't want to do another method. I want to at least talk more about this and go from there. All right. Thank you.